Problem says an airplane is climbing at an angle of 55 degrees with the ground. How fast is this plane gaining altitude in miles per hour if its current speed is 450 miles per hour? I'm going to draw a picture of the plane. Alright, so the current velocity of this plane is up and to the right. That's the direction of it. It's making a 55-degree angle with the ground. And so we could construct a triangle here. We can find an x, a horizontal displacement for this plane, and also a y. So in physics, those terms would be called a vertical displacement. And this one would be a horizontal displacement. The green here represents the velocity vector of the plane. It has a size of 450 miles per hour. That's the speed of it. Now they want to know how fast is the plane gaining in altitude. So you could call this gain in altitude a dy over dt. That's what they're asking us for. Okay, they have a speed which has a formula of distance divided by time. A lot of times when we're doing a right triangle kind of situation, we could let this distance here be represented by c, or perhaps h for hypotenuse. Yeah, let's just use h. So that speed there is dh over dt. So they gave us that. We know dh dt is 450. So we need a relationship between the quantities that we have and the one we want. So this angle here is given. And so if we use a little bit of trig, according to trig, we have the SOHCAHTOA idea, where the sine of an angle is the opposite over the hypotenuse. Cosine of the angle is going to be the adjacent over the hypotenuse. And then the tangent of the angle is the opposite over the adjacent. So we're looking for a relationship between the opposite leg and the hypotenuse. So what's their relationship according to trigonometry? We could use sine, this one here. Let's just say the sine of theta here is going to equal y over h. If I solve for y, I get that y equals sine theta times h. I would want to plug in here. The angle is going to be constant. It's going to be 55 degrees. We would want to differentiate implicitly now. And we'd get that. Then I would divide by dt on both sides to reveal the relationship between the rates of dy dt and dh dt. We could now plug in the dh dt that we were given. So I'll plug that right in here. We could now find dy dt. I get 368.6 miles per hour. And that would be like a vertical velocity or a vertical speed in the upward direction.